Hello everyone, welcome to the class. Let me just check if I'm online. Hello Akshay, good morning. So in today's class, we are going to start with your Unit 2 Kinematics, but we will first see the concepts of motion in a straight line before we go into the motion in plane, where you will be learning about vectors. Okay. So in today's class, we're just going to cover basic concepts. Alright. So again, once again, my name is Mohana. I'm a physics educator at Unacademy. So I'll be basically taking your class 11 and 12 ISC physics. And this I've shared my Telegram group link, right? All updates before any channel, right? All the updates will be shared in my Telegram channel before going live to any class. Saman, can we study ISC and do NEET at the same time? Yes, Saman, you can. Okay, and then you have the Telegram channel. Then this is the common Telegram channel. This is Unacademy ICSC and ISC boards common Telegram channel. So you can actually join here as well. So any updates will be shared in these channels. Okay, so right. So then again, just like how we have free classes on the YouTube channel, we also have free classes in the Unacademy platform itself. So these classes are absolutely free. You can learn from any of your favorite educators. Then again, you can engage. We have a pool feature. So basically, when there is classes happening, if you're learning a concept, there will be some questions asked in the about the concept, or we can ask any. Even if it's not related to like how interesting the class is, okay, or anything, like you can actually share your feedback also to your educators via this pool, right? So you can actually engage with the educator via this pool feature, right? At the same time, these classes are also again live special class. These classes are also live classes, so any doubts you have, you can get your doubts cleared then and there. So the next special class that's happening on the Unacademy platform for ICSE board is today. The class is at 4 p.m. and the topic we will be discussing would be introduction to impulse. So we will be looking in the topics of from the dynamics. Okay, so we will be learning about Newton's laws of motion. So that is the topic we will be covering in today's class. So do join. And to join the class, one thing is there is a link in the description, right? You can actually click on that link. It will take me to the channel and you can just enroll for the class there, and you will be notified when the class starts. Okay, otherwise you can just use my code MTIS10 to access any of my previous pre-classes as well. Now, in case if you're interested in the Plus subscription, so Unacademy's Plus subscription has these advantages. One is you can learn these classes at the comfort from your home, right? And then you will have unlimited access to all the courses, okay? And as well as you will be learning from top educators, because all educators on the platform are good. And then every fourth session, let's say today a batch is starting, the fourth session, every fourth session in any of the batches is always a doubt clearing session. Okay, so any doubts you have in the previous classes that you learned, any doubts you have, you can get them cleared in these classes. Next, in Plus subscription, we will cover your entire syllabus. Then we also have the live test series. So anytime, every weekend there will be live test series. So you can take these tests. You can see whether you've understood the concept well or not. Anytime you want to take and know whether you've understood the concept or not, just go take any tests. All right. So in that case, we even have the live test series. So you can attend these live test series, and after the live test series is over, there will always be an analysis session as well. Okay. Now the new batches are coming up from June 8th, so you can check them out as well. And the pricing, if you look at for the courses, whenever you're taking for a longer duration, let's say instead of 1 year, if you're taking the course for 2 years, then the price per month comes down. Okay, then on top of that, if you're using my educator code MTIS10, you'll be getting a 10% discount on any plus subscription that you're taking. Now the Unacademy is also conducting ANSAT. This is Unacademy's National Scholarship Admission Test. Okay, this test will be a computer-based test, but it will happen in the offline centers across 40 cities. So in case if you're preparing for IIT JEE or NEET UG, or you're in class 9 and 10, okay, and preparing for, and you want to take fundamental courses, so before enrolling, right, what you can do is you can take this test that's on June 2nd, right, and so you have to register for this test by around June 2nd, and if you come in the top 40 ranks, okay, you have a chance of winning an iPhone. Depending on the top ranks that you're getting, you can get even up to 90% scholarship for taking these NEET, UG or IIT JEE or fundamental courses with Unacademy. So either if you're taking them from the Unacademy centers, or even if you're going for plus subscription, in both cases the scholarship apply. Now the test has for the test you need to pay around around 199 rupees. So you can use my code MT IS10 to avail a 10% discount on the same. Alright, with that note, the previous classes that we have been doing till now, we have been actually studying about physical world and measurement. So there is a class in today evening around 6:30. We have a class. Again, in that class we will continue physical world and measurement, but the morning class today and also tomorrow will be on kinematics. In kinematics we are going to cover the topics just motion in a straight line. Okay, now before we go ahead and learn about motion in a straight line, first we need to understand what is mechanics. Now this mechanics is basically a branch of physics, okay, and it deals with the condition of rest or motion of any object that is around us. Whether a particular object is at rest or in motion, all of that are studied in mechanics. This mechanics is under the branch of physics. Now mechanics is again sub-classified. Do you know what are the sub-branches of mechanics? Anybody has any idea what will be the sub-branches of mechanics? One will be statics. Another sub-branch of mechanics is kinematics, the subject that we are studying right now, and then dynamics that you would be learning in your unit 3. Now, statics actually deal with the study of object at rest or in equilibrium, okay? Even when they are under an action of several forces, these objects are always at rest, okay? Measurement of time in this case is not essential. The example for static is if a book or any object that's lying on your table, right? The book that is on your table, right? There are forces acting on it. There is a gravitational force acting down on it, right? Between the table and the book, between the table and the layers between the table and the book, there is an electrostatic force acting between them. But irrespective of any force that is acting on them, right? The object remains at rest. Any object that's at rest is actually known as is actually studied under statics. All right, kinematics. Now kinematics, this deals with study of object or study of a motion of object without considering what was the cause of the motion. We are not worried about the cause of the motion. In this case, time is very, very, very essential, but we study objects which are in motion. Okay, Chinmay, good morning. All right, we study objects which are in motion. So can you give me an example of this objects? That's okay, Chinmay, we are just starting. So what do you think? What is an example of kinematics? Of statics, a book lying on a table is an example of static. What will be the example of kinematics? A car traveling on a road, that's right. Any other examples? So kinematic here comes from the Greek word, sorry, one second, kinema. It actually means motion. All right. Okay. So this is about free fall, planets revolving around sun. Okay. So in all of these cases, if we are not considering what was the cause of this, we are not worried about what caused these motions. Okay. If you're talking about the car traveling on a road, we are not a moving car. Okay. We are not worried about that. Okay. And what was the cause, that is what is the force that is acting on the system, we are not worried about it. Okay. Planet revolving around a star, we are not worried about the gravitational force, we are not taking force into consideration at all. Okay. But if you're studying object of motion, right, without considering what the cause of the motion is, then it's kinematics. What do you think we will learn under dynamics? How is dynamics different from kinematics? Chinmay, considering the force, I guess, differential calculus depends on the kind of questions you're dealing with. But yeah, in your class 11, there is not much, you need to at least have a basic idea of differential equations or, calculus. But yeah, it's not very hard. Okay, force is related to motion. Yeah, that's dynamics. If you deal with the subject of motion, right, of object, taking into consideration what was their cause, right, then it is dynamics. That dynamics is considered with the forces which cause this particular motion. Okay, that actually deals with your dynamics. So these are the three sub-branches of mechanics. One is statics, kinetics, dynamics. So motion in a straight line, motion in a straight line, motion in a plane, all of this comes under kinematics. Okay. Third unit, the laws of Newton's laws when you're studying, that actually comes under kinematics. Okay. So with this, we'll go on to what is rest. What do you think is rest? Rest is basically when an object is said to be at rest if it does not change its position with respect to its surrounding with the passage of time. What is an example of an object at rest? An example of an object at rest. Right, Akshay. But what would be an example? A book lying on a table. Yes, that is at rest. Okay. An object in motion, right? An object in motion is said to be in motion if it changes its position with respect to its surrounding with the passage of time. Okay. What would be an example of an object in motion? An example of object, a moving car, yes, a train moving, any object that you're seeing that is actually movement, a bird flying, right? All of these are actually is said to be object in motion. Okay. Now both these rest and motions are relative terms. Why? For example, if you want to study whether an object is at rest or motion, right? You have to consider one particular object, right? You need something that is for reference, right? And that reference object that you're taking should be at rest, right? So if there is a reference object that is at rest, and with reference to that object, if you're looking at the other one, then you can know. Okay. But then you can know whether the other object is at rest or not. But the reference object being at rest is not possible, right? Because if you look at us, we are on earth, right? And the earth is moving, earth is going around the sun is again going around the planet. So everywhere on the universe, if you see absolute rest or absolute motion, that is one object is complete rest with respect to another, is not possible. That concept is not there. But whenever we study about rest and motion, we study it from the point of whether it is rest with respect to another object or motion. Okay. So rest and motion, these are called as relative rest terms, because we study about rest mass and rest motion with respect to another object. For example, if you're standing in the platform of a train, okay, if there is a train passing by and if you're standing on the platform, okay, you are at rest and the train is moving. Now, in case for a passenger sitting in the train, and if the train is actually moving, for them, right? So for them, they are actually at rest, okay, but the outside, whatever the outside, the other trains that are passing by, the trees that they are coming across, right, all of those are actually moving and you are at they are at rest, okay. So you study rest and motion depending on two different frame of reference, okay. When you are standing on the platform, you are at rest because you are on the ground, you are at rest. When you're looking at the train is actually moving. But imagine if you are sitting inside the train, how would you feel? You are actually at rest, but everything around you is actually moving. Okay, so motion or rest we are studying are always relative to, or we are studying about relative rest and relative motion. Okay, relative to one object or another. All right. Okay, now what is a point mass? Okay, now an object is said to be a point object or a point mass if it is changing its position. In case if it is changing its position, right, changes in its position is very large as compared to its own size. Okay, then we say such an object is a point mass or a point object. Okay, we can call it as a point mass, as a point object, in case if its changes in its position is very large when compared to its own size. Can you think of an example of a point mass or a point object? Point mass or point object? The object size itself is very small when compared to the how much changes it in the position it has. So in the previous example that I gave, the person who's standing on the platform can be taken as a point mass, right? Wherein when compared to the train that is passing on the passing through the platform. Okay. In case you can consider Earth, you can consider Earth as a point mass. Correct, Akshay. Earth being a point mass is correct, or a point object. Okay. Since the motion around the sun, since their motion around why? Their motion around the sun, right? When it is going around the sun, right? The motion around the sun, the distance that is covering, the motion around the sun itself is very large, right? Is very large when compared to the size of the Earth. Okay. Compared to its size. Okay, such an object we basically call them as a point mass. Akshay is saying motion of Earth around sun. That is correct. All right. Next, now let's learn about the motion in 1, 2, and 3 dimension. Okay, what is a one-dimensional motion? Can you think of an example of a one-dimensional motion? Example of a one-dimensional motion. What is an example of one-dimensional motion? A ball rolling on a floor. Okay. Okay, so if you have three axes, right, we have three coordinate system. If you take x-axis, right? We have x-axis, and if you take y-axis, and if you take z-axis, any object, okay, which has a motion only along the one coordinate of this axis, okay, so an object in motion is said to be one-dimensional, okay, in case, okay, when any one of the three coordinate action is used to specify the position of the object which is changing with time. Okay, example is, if you see a car that is going on the road, okay, now the car's position is changing with time, right? Car on basically the motion of the car on the road, right? The position of the car is changing with time, right? Somewhere the car is over here, after some time if you see, the car is over here. So position of the car is changing with time, but, right, and in this case the position is also is in one dimension. You can just use the x coordinate to give the position in this case. A boy moving on a horse in a straight line. Yes, in all of these cases, one-dimensional motion is also called as a rectilinear motion, because in this case, right, a train, yeah, anything that is going in a straight line. Okay, so in one-dimensional, if you're using only one coordinate axis, you're not using using the three coordinate axis. If you're just using any one coordinate axis to explain about its motion, right, with that change in motion with time, then where is its position with time, okay, then basically that's called as a one-dimensional motion. Okay, now what will be two-dimensional motion? What will be a two-dimensional motion? Example of a two-dimensional motion. Example of two-dimensional motion. One-dimensional, usually we are just making use of one coordinate axis. Now when we say two-dimensional motion, now we are going to need two coordinate axes. So basically we will be considering any one of these planes. If you're taking, right, if you're taking two coordinate system to explain the motion of an object, right, is a car moving on the road with the turns, again, Akshay, that again is basically one dimension. Okay, at any point there is a change in that direction, right, you can still explain with with one of the coordinate axes itself. For example, if it is coming in this direction, right, let's say the car is moving in this direction, right, then you can say it has two coordinates, right, but this, if it's going in this direction, then I can make this my y-axis and I can make this my x-axis. I can still explain the motion of the car, right, in just using one axis. When you say two-dimensional motions, right, you will at least need two of the three coordinates to specify the position of the object with change in its time. You're now going to need two dimension, right? So example for a two dimension. A ball falling from a turn. How about the motion of the planet around the sun? Anything that is going in a circle. Motion of a boat in river, what is the motion? Is it going in a straight line? Is it going in a circular path, right? Motion of a boat, it's similar to, again, it's like going in a car, right? Right, in two-dimensional motion, an example you can give is motion of a planet around sun. That's a two-dimensional motion. Okay, a body that is revolving in a circle. If you have a fixed point and the car is just going round and round and round under this fixed point, right, anything that's in motion, right, the motion of a planet you can explain with your two dimension. And also insects crawling over on a floor, that is also an example of a two dimension, right? So basically when you look at one dimension over here, when you basically look at one dimension, right, you just use the x-axis coordinate alone. If this is the origin, let's say the position of the object was somewhere over here. Okay, after some time the position of the object is somewhere over here, right? Then the position of the object, this is the first position, this is the second position, this is being the x-axis. So the first place, right, 1 second, right, so this distance from the initial to here, it has covered a distance of x1. With time, after particular time, it has covered a distance of x2. This is basically motion in one dimension, and this is also called as your rectilinear or linear motion. Okay, motion of a free falling body, motion of a train along a straight track, all of these are rectilinear motion. But even if you're taking the motion of a planet, right, around the sun, and in case if you're taking the motion of a car, if it's going completely in a circle, or in case if it is going in an extremely zigzag path, and the motion of an insect, even if that is going zigzag, then you can use all of that to explain motion in a two-dimension, right? Then this is basically two-dimensional motion. Okay, so in two-dimensional motion, two coordinate axes are needed, right? One, you need your y-axis, another you need your x-axis. Okay, now let's say at some point the object was over here in the xy plane. Okay, now you need two coordinates over here. You need x1 and y1, 2 points. Okay, to explain its point, at this point over here, if you see, this distance of this is x1, right? This position basically gives you the x1, right? And if this distance actually gives you your y1, okay, somewhere over here. Now after some time, this object is somewhere elsewhere, right? This is p2, so it will be x2 comma y2. So from here, if you see, this has been x2 and this one has been y2. So if you're using two coordinates, okay, two-dimensional, okay, if out of the three axes, if you're using two coordinate system to specify an object's positional change with time, with time using two coordinates, right? Using two coordinates. I'm sorry, just give me 1 second. Okay, using two coordinates, then that's a two-dimensional motion. Okay, really sorry. Right, a car going in a roundabout. Okay, all right. So these are an example of two-dimensional motion. Okay, then what will happen to a three-dimensional motion? What is a three-dimensional motion then? The motion of an object is said to be three-dimensional. When do we say? Space, in this case of three-dimensional, you take all three axes into consideration. That is true. Okay, so can you tell me an example of a three-dimensional object? So basically you have all three axes into consideration. You have your x-axis, right? You'll have your y-axis and z-axis. Okay, let this being the origin, please. Right, in this case the object is somewhere over here. Okay, this basically gives you the position, first position, initially the position of the object, right? Z1, let's say it's somewhere over here. Okay, in this case we can say, right, this position being my y1, this being my x1, and this being my z1, right? This is the three axes. Now after some time the object is somewhere somewhere over here, we can say the position of the object has changed with respect to time. The position of the object is changed. Okay, then this object has gone somewhere from here to here, it has changed, right? And now if you consider this, right, now this distance is basically your y2, right? This entire distance will be x2 and this distance will be your z2, a three-dimensional object. Okay, okay, so a spaceship in space, yes, okay. And what other could be a three-dimensional motion? How about the flight of a bird? A bird flying, that's a three dimension. You're basically taking x, y, and also the height, z coordinates, right? And also in case a flight taking off, right, as the flight is flying high in the space, right, that's again a three-dimensional motion. Okay, and because here the height coordinate also comes into picture, right? And can't understand the z coordinate. Okay, think about the height. Okay, let's say this is the ground. You might just think this is the ground. Okay, right, this is the ground. Okay, a bird is somewhere in this position. Okay, or do you know how to they usually play with kites, right? Do you know how to fly a kite, right? As you fly the kite, what happened? Ritik, hello, right? As you fly the kite, what happened? Its height increases. It is going a distance with time, but also its height also goes high. Okay, now anything that's flying on the sky, right, your birds is a three-dimension. Okay, it has three dimensions. Your flight, right, flight that is flying on the sky has three dimensions. Okay, a motion of a kite is basically a three-dimension. All of these uses a three-dimension because it has the height, that height is also into consideration. Think of a car that is just going round and round and round. Okay, in one spot, let's just think that the car is going in an extract zigzag, okay, or an insect that is going in a zigzag motion. Okay, now this we say there are two dimensions, right? Now what happens? You're taking the height coordinate also into consideration. When the bird is flying, if it's going in a zigzag position, at the same time it is also flying at a particular height, right? Now three dimension comes into picture. All right. Does that help, Chinmay? Okay, now another basic question, basic difference. What is a scalar quantity and what is a vector quantity? What is a scalar quantity and what is a vector quantity? What will be your scalar quantity? What will be your vector quantity? A scalar quantity, something that only has a magnitude. Okay, Chinmay, that's right. Scalar has magnitude. We are not worried about the direction. Okay, vector quantities have a magnitude. Okay, and a direction. That is right, Chinmay, you're correct. Okay, now let me give you, is distance a scalar quantity or a vector quantity? Akshay, that is right. Scalar does have a certain magnitude but no direction. That is right. Okay, scalar. Okay, Distance is a scalar quantity. Okay. Have you heard of this term called displacement? Okay. Right. What about displacement? Is displacement is a scalar or vector quantity? Displacement, is it a scalar or is it a vector quantity? Displacement, Chinmay, you're right. Displacement is a vector quantity. Okay. Now, what is the difference between those two? When you're talking about distance, you're talking about some length or some distance that is covered. Displacement also talks about the same. But what will be the difference between these two? Shortest possible distance from initial to final position is displacement. Okay, that is right. All right. Let's say you're in your house. Let's say you're in your house. Okay. And from here, from your home, you actually have to go to your school. Right? And okay, your school. Okay, and the distance from your home to your school, I'm taking in terms of kilometers. Okay, let's say this is 2 kilometers. Okay, now usually right now what do you think? What is this? Is this a distance, or in the second case, let's take another case as well. Okay, now usually whenever we are going from home, let's say from your home you are going to some place, your friend's house. Okay, and from there your friend's house and you, let's say you're going to your tuition centers. Okay, you're taking your tuitions. Let's say you're going to your tuition center. Okay, one more pit stop, and from there let's say you're going to a bakery, any eatery. Okay, and from there you're reaching your school. Now for you to go this entire thing, let's say it took you 4 kilometers. Now this entire route from your house to your friend's house to your tuition centers, then back to bakery, and then to your school. Okay, now between these two, which is distance, which is displacement? Akshay is saying 2 kilometers is displacement. Akshay, that is right. So this quantity that you see, right, the shortest distance from your home to school, this is basically your displacement. Okay, and what about this? The other 4-kilometer route, the route that took you from your home to your friend's place to your tuition center, then to your bakery and back, right? Chinmay, 2 kilometers being displacement is right. Okay, this entire Chaitana, hi, right? This entire Chaitana Kumari, I think I've seen you in my other class as well, right? First or second classes. Hi Chaitana, right? Right. So here so here this entire 4 kilometers, this is basically your this entire distance, this you covered, this we call it as path length. This is the entire length that you covered, or we will say it as distance also. Okay, distance and path length, when you're talking about the same quantity. It is talking about what is the entire path that you have covered. That is, in this case you have gone 4 kilometers. Okay, the entire path from the initial, being your initial position being your home, okay, to the final position, this is your initial position being your home, to the final position being your school. Okay, now this is basically your initial position to final position. If you're taking the shortest straight route, that is displacement. But you're taking a whole roundabout path and going, that is your distance. That we also say as path length. Okay. Now, from here, okay, how do we define velocity and speed? You've done this in your 10th classes, you'd have come across this, right? So instead of me starting it as a new, let's just check how your knowledge on velocity and speed is. Which is velocity, which is speed? Which is basically velocity, which is basically speed. How do we define velocity and how do we define speed? Which quantity would be, how would you using these? Rate of change of position. Okay, so basically if you want to say, if you went from your home to school, you traveled only 2 kilometers. Let's say you travel 2 kilometers in about how many minutes? Let's take kilometers per let's take per minute. Okay, let's say you took about 10 minutes. Okay, but to cover this entire thing, let's say you took about 30 minutes, right? Then when you say speed, right, your speed is basically Chaitanya, today is your birthday, happy birthday Chaitanya, right? Today is your the speed is basically given by the distance traveled of an object in unit interval of time, right? It's basically called your speed. So speed is basically given by distance by time travel, right? The speed is basically given by distance by time taken. Okay, by time taken. So here the distance is nothing but 4 kilometers and time taken is 30 minutes. Alright, so 4 by 30, right? You have 4 by 30 kilometers per minute. Okay, but what is the SI units? How should we actually represent this? What is the SI units of meter and time taken? Can you give me the answer for speed, distance by time taken? That is this entire thing. That is distance by time taken is basically your speed. And velocity. Velocity will be nothing but displacement by time. Velocity will be displacement by time. Okay. Here velocity displacement is basically 2 kilometers by 10 minutes. Okay. Right. So what is the speed and what is the speed? What is the unit? So usually here we are given in kilometer per minute, right? Per minute. Here the answer you get is basically in kilometer per minute, and here 2 by 10 is basically what? 1 by 5, that is right. This is again in kilometer per minute, but usually whenever you give the answer you have to convert this into meters per second. Alright, always give Chinmay, that's right. Akshay, that's right. Always give it in terms of meter per second. Unless otherwise the question specifies you to give it in terms of the speed. Okay. So here, right. So in these two is which is a vector quantity, which is a scalar quantity. Speed and velocity, which is a vector quantity, which is a scalar quantity. Kilometers to meter, sorry, your speed to velocity, which would be a scalar quantity, which would be a vector quantity. Akshay is saying speed is a scalar quantity, distance was a scalar quantity, right? So speed is a scalar quantity. When we are talking about speed, we are not worried in what direction direction is not taken into consideration. But whenever we are talking about velocity, right, displacement, when you're talking about displacement is a vector quantity, so velocity that you're talking about is a vector quantity. Okay, so whenever we say velocity, okay, now whenever we are saying speed, okay, the speed in which a car is traveling is around, let's say, 40 meters per second. All right, that's okay. We are just worried. We are not worried in which direction it's going. We just know that it's going in 40 meters per second. Now, if in case, if I say the velocity, okay, now you're going to your school, you're going to the school, going to your school at around if you basically, if you say over here, you're going to you're going towards your school in a car, right, in around 5 meters. The speed in which you're going towards your school is 5 meters per second in from your home. That is the speed you're going in. Now, what comes into position? Your velocity. When you say velocity in which you're going towards your school, right, in which a car is going from home to school, right, is 5 meters per second. Then which direction is it going? Is it going towards north? Is it going towards south? Is it going towards northeast or northwest? Okay, that comes into picture as well. Okay, that's the difference between velocity and speed. Speed, we are only worried about the magnitude. We don't care what the direction is. But in case of velocity, we are also taking in terms of talking in terms of the direction in which it is. Okay, so when you're going from your school, think about yourself going from your home to school. In case if you're saying I am going to my school at the speed of, right, the time taken, or that I'm going into my school at 5, the speed in which, the velocity in which I'm going towards my school is 10 meters per second. Towards what? Your school is towards which direction? That also comes into picture. Okay, now let's see one more case. Now that we saw this, let's see one more case. Okay, all right, let's see one more case. Again, same example, going from school, going from home. Okay, and this time you're going from your home to school. Okay, right, and let's say you're also on your way. There is 2 paths that you're taking. And another day you're going through your friend's place, right, friend's place, and then to your school. Okay, right, now there are 2 routes. One is you're going from home to school. Okay, you reach your school, right, and let's say you turn back home again. You're feeling sick or whatever reason, you're coming back home again. Okay, you're going to school and coming back home. Right, now from your home you're going to your friend's place, right, from your home you're going to your friend's place and back to the school. Right, now let's say this took you this path, right, this path that you're taking. Okay, you're going to your friend's place to school. Okay, and in this case you started from your school and you're going back. Right, so as Chinmay is saying, in this case what will be displacement? Akshay is also saying displacement is 0. That's right. Why? Displacement is given from what is your initial position to final position. What is the difference between your initial position to final position? Okay, if this is your initial position, okay, and this is your final position, when your initial position was 0 and let's say your final position is a school that is at 5 kilometers, right? So your displacement is nothing but this difference between them, that is 5 kilometers. Now you went 5 kilometers this side and you came back 5 kilometers this side. Your initial position is here and your final position is also here. Right? You started from home, you went to school and you came back to home again. Right? What is the displacement? Displacement is 0. Okay? So displacement can become 0, but distance, okay, distance can never become 0. Okay, it returns to its initial position back and from final position, so it becomes 0. That's right. Right, whatever is your initial position, you're back over there itself, the final position, because displacement is talking about shortest time. Okay, so displacement can become 0. Right, now if speed is given as distance by time, okay, what will be its dimensions? What will be its dimensions? The dimension, speed is given by v, its dimension, that is right Chinmay, right, dimension will be here distance. It is basically talking about what was the length that we have traveled, right, the length that is covered, right, that is actually given by meters, time is given by seconds. So here mass, if you see, it is basically 0, it's not there, so you have length and time inverse. So you can say the dimensional formula of velocity is basically length per L T inverse 1. That's your dimension formula. Okay. Now right now there are certain characteristics to displacement. Okay, the displacement that we are talking about can be positive, right, it can be negative, right, and this displacement being 0 we just spoke about, right, if in case you have an object, okay, if you're going from home to school and back, then it becomes, the displacement becomes 0. All right, now what will be a positive displacement? Okay, let's say for example, okay, let's say over here, okay, let's say this is the initial position, this is O, okay, from here you've traveled this path A, this is your next position, this distance you traveled is x1, okay, this is the position of the object after some time. After some time, let's say the position of the object is somewhere B over here, okay, now this distance, if you see, this distance is basically x2, okay, here if you see x2 is larger, x2 minus x1 is greater than 0. In that case, right, if the displacement changes that you're seeing is greater than 0, then it's a positive displacement, okay, right. Similarly, if you have an object, right, in this case, if you have, in this case, you, let's say this is origin, okay, after some times, okay, let's say this is the initial position, okay, this is the length traveled first, let's say this is x1, first someone is over here, right, this could be like, you know, you going from your home to school, and school to let's say your a bakery, okay, from home to your bakery became the final destination, okay. Here if you see x2, the second distance that you're saying from the first to the second distance, if you consider, this is 0. Now in case if you're going directly from here to any eatery, okay, let's say that distance is x. Now from your home, then you're coming back to your school, okay, B, and if this distance is x2, right, so in this case what is happening, the direction in your traveling is in this time. If you're just going in one direction, whatever was this distance added to that, you've gone to your school, from your school you've gone to the bakery. But what is happening here, you've gone to a bakery, then you're walking back towards your school, okay. So this is your home, this is basically your home, let's say this is your school, and any eatery, okay, or a bakery, right, or a juice shop, anything that you're going to. From home to school you're going, and from school to bakery you're going. That's a positive displacement, okay. Now in case if you take a roundabout, okay, what you're going to do, you're going to go from your home to bakery first, right, then you decide, okay, then I'm going to come back to school, right, that distance is more, and then you're going to walk back towards school, right. Now if you see this distance that you're covering, right, this distance that you're covering over here is basically what happens, you've traveled to a distance of x2, right here. Now x2 minus x1, what will happen? This is a small number, this is a greater number, right? x2 minus x1 will be less than 0. So this will become a negative displacement. Okay. Right. Now, zero displacement, we just saw what is a zero displacement as well. Okay. So, negative displacement. Guys, just give me 1 second. Just give me 1 minute, I'll be back. Right. So in today's class, what we covered was nothing but we just learned what is what is rest, right? We just covered what is rest. We learned about the branches of mechanics is a branch of physics. The branches of physics we looked at. We learned what is rest and motion. Then we learned what is the concept of point mass. Then we saw motion in a 1 dimension, 2 dimension and 3-dimensional motion, how they're different. Okay. And also we just basically began what is distance and displacement. Okay, we are just learning it through examples because these are concepts you would have already learned, and also you would have learned about speed and velocity. Okay, and in case of displacement, we learned what is a positive displacement, negative displacement, and also what is zero displacement. Like zero displacement, if you're going from your home to school and back to your school, that's zero displacement, or any object that is stationary, that also has zero displacement. Okay, so at this note, we are coming towards the end of today's class, right? And once again, we are coming up with new batches. But before that, today at 4 o'clock, you have a class, right? Today at 4 p.m. in the Unacademy website, we have a class that is for this is basically for, we would be discussing topics from your dynamics, right? So you can actually join the class. There's a description link below. You can click on it. It will take me to my page, and you can say notify me. So when the class goes live, they will actually you will get the notification. The next class for measurement is at today 6:30 p.m. Tomorrow same timing we will join for kinematics. Okay, Chinmayavan sir, next class again we have for right. So we have 3 classes, one at 4 p.m, one at 6:30 p.m. Tomorrow again same timing we have for kinematics. Okay, 6:30 class will be continuation of the measurement topics we have been doing. The 4 o'clock class that is happening on the Unacademy platform will be for your 3rd unit. Alright, so we are coming up with a new batch that is starting on 8th June, right? So this is the first class, right? This is a new batch itself that is starting. So the target of this batch is completing your midterm syllabus, right? We will be starting from unit 1, physical world and measurements, what we have seen, and we'll be looking into the first 5 units. The mode of delivery will again be English. I'll be taking physics. I will be taking class every Tuesday, Thursday, Saturday between 5:15 to 6:15 p.m. Jyoti ma'am will be taking math, Manisha ma'am will take chemistry, and Lakshay sir will take biology. Now again, if you want to take the plus subscription, I think there is a number down below in the description box, right? You can call them, they'll give you the rest of the details as well. And if you're using my code MTIS10, you can avail the discount. Alright, and also the UNSAT, this is the Unacademy's scholarship, National Scholarship Admission Test is going on. This is in case if you want to take if you're going to attend your IIT JEE NEET UG in the upcoming years, or in case that is in 2023 onwards, or if you're in class 9 and 10 and if you want to take your the foundation courses, right, the fundamental courses, the foundation courses for IIT JEE, then this test is this scholarship test is apt, because this would be an offline test. Basically, it will be computer-based test in the offline centers of Unacademy. That is, and in across 40 cities, this test will be conducted. Okay, but if in case you come in the top ranks, you can win an iPhone. Top 40 ranks can win an iPhone. All of the test takers are getting the Unacademy t-shirts. And also, depending on the what top ranks you're getting, you can win up to 90% scholarship to study with Unacademy's. In case if you're taking Unacademy's IIT JEE or NEET coaching, NEET subscription, then you can win up to 90%. Depending on your rank, that scholarship percentage will change. And again, this scholarship is available in case if you're taking for an offline center, as well as if you're taking an online subscription also. The last date for registering is on June 2nd. Okay, at the same time, if you're using there is a registration fees is around 199 rupees, and if you're using my code MTIS10, you will be getting a 10% discount on the same. Okay, so to unlock the special class today, right, you can use my code MTIS10. Now again, you can actually follow me on my community feature as well. You can see there are some 2 pool questions. You can try answering them. Okay, and you will, in case if you can follow any of your favorite educators community, right, so that you can stay updated on all information, right. You can follow them in Telegram as well as the community channel. And also in case if you're getting any inappropriate content, okay, if you're seeing any inappropriate content in any of the videos, and if you're reporting the same, right, you will claim a prize. And click on the bell icon to subscribe to the channel so that you can stay updated on the upcoming classes, and like and share the class as well. Thank you guys. I'll see you in the next class.